Hi guys, this is Nitin and I am back again. And this time I have a special video about retail analytics. If you guys remember, I did a video about training a object detection model for retail analytics application a couple of years ago. And by far, that video is one of the most viewed videos on this channel. So I know how much the community loved it, and I wanted to share with you more updates about how the pipeline has been evolving over the years. So today I'm going to talk about the application part of it, that is how I'm utilizing the retail analytics object detection model to actually build an application around it. And this is going to be a very interesting video. I'll show you a lot of cool features and how I'm able to build a image recognition pipeline using it. So let's jump straight into the video and I'll show you the demos. So here we have the home screen interface, and what this essentially does is here you can drag and drop your images to process it and visualize how well it is performing. Actually, this is part of an internal application. The overall pipeline has a lot of moving parts, and the final goal is to ingest the incoming photos or images collected by people from all over the country, and then our pipeline basically processes those images to generate statistics for the brand identity or the product information. So this part, it's called image processor. What it does is I will show you some demo here. So I have a couple of images here and I'm going to select few of them and see how well it works. So let's select this one and not this one. Let me select these three. Okay. So you'll see whenever I select multiple images, it will automatically load them and then we'll start processing it. And within a couple of seconds, this has been processed. And you would see that there are multiple bounding boxes around these objects or products actually. So what happens is when I move my cursor over onto the product, you'll see these object boxes are interactable. And let me try one more image. I know there is one image for which I have information in the DB. Let's try this image. Okay, so this is another one, and you will see this product is actually part of the internal database. So the information about this product is available to us. So now let me quickly talk about how this all pipeline works. So there are two microservices involved here. One is your main image processor application, and another one the backend supporting the detection recognition pipeline. We call it as computer vision API. So what it does is it detects the products, and once the product is detected, it crops out the product and then compute the embeddings for it. Now I'm using quadrant vector database to store the embeddings and the product SKU. So whenever a new image is processed, its product embedding is calculated and then it is searched through the vector database to find the SKU for it. Now once this SKU is found, we take, let's say, top one prediction. Now this SKU information is stored in internal database. We call it as data delivery. So the application goes and look through that database to see if it can find the SKU information there. So here for this, especially in this product, because the information available in the internal database, so I'm able to see the product name, brand, and other information, and it shows a similarity score of 85%. And similarly, for example, this product, it shows not available because even though this image is indexed in our CV API, but because the product information is not yet available in the data delivery, so we don't see any information related to that product. It is only recognizing it. And the way this is developed into two parts, the data delivery and CV API, and not storing the information in CV API, is because this helps us to build the index. So initially, if we don't have the product information available, but what we can do is we can find some crop over the internet and index it. So whenever we try to recognize an image, the product will be recognized, the SKU will be predicted, and later we can add it as a product so that in the CV API. So I was saying we can find this information on the internet, put the indexed image, and then use it to create new products. So that's the overall pipeline. And let me show you what happens if you have a wrong prediction. So for example, here, this is a product and the prediction is wrong. It only shows a similarity score of 62%. So there are two options here, yes or no. So basically it asks whether the prediction is correct or not. If it is correct, but the similarity score is less, then the user clicks on yes. What it does is it takes this newly found image and the SKU from the predicted image and then index it, so that next time whenever we try to search through similar product image, using its embedding, the accuracy will be high. If not, if the prediction is not correct, then user can click on no, and then this new model is shown to the user. So what it does is it will show you all the top k predictions. Usually we show 50 predictions, and in case if the product which is detected here, if any matching image for that product is available in our index, it will be shown here, and then user can just click on it and then save it as a new image and SKU pair, so that whenever next time this new same image is processed, the crop which we saved will be indexed with a higher score, and that will give us more chances to find the correct SKU for that product. Now interesting things to find here is you can see in the image grid here, there are boundaries or borders over the images. Some have yellow, some has green. So the yellow one basically means these are actually all of these images are coming from the CV API, because these are indexed as an image and SKU pair. But some images have green borders. Reason for that is because the data information, product information for that SKU is available in our data delivery. So user can be sure that if there is an image which matches with the detected image and it's in green, which means it's already created, the product information available, so they can safely select it. If not, then the yellow ones are only indexed for prediction purposes, but the product information is not yet available in the database, so user can select either of these. There's also an I button here to see the hover information about the product on hover, and if some prediction is coming out wrong, then we can also delete it. Now let's move on to the search SKU part. This is also interesting. So what happens is, let's say you have this product on the left which is detected from the input image. Now you want to link it with some SKU or product information. How would you do it? So one idea is you already know the SKU. So what you can do is you can go here and put some SKU. Let's say I put PH10 here, and I can look into data delivery whether any SKU with this information available in data delivery or not. If available, I can just link it with that product. If not, we can go to CV API and we can see that there are products available with PH10 as an SKU. So in case if it is the same product, I can just click on it and then link these two images. If not, I can also do manual entry. So in this case, I will just enter any SKU here, and anything which I think is the correct SKU for it, I can just put it in the database. Oh, interesting thing, if I select to CV API and select any product, I still have an option to modify the SKU so that I put anything that is important into the database. Let's move on to the next big thing, that is reverse image search here. So these are powered by Google Lens and Yandex Images, and my goal is to let the user do the reverse image search, figure out the SKU, and then put it manually. So let's say user clicks on this Google Lens here. What happens is it takes this product crop and then use Google Lens API to open it as an reverse image search query, and then figure out all the products listing. And what the user can do is basically if they find the product image match, they can go to the website, figure out its SKU, copy it, and put it manually. Even though for this product I don't find a particular information, let's look for some other one. So I go to this one. Already this is indexed, but I think this is easier to find, so I will just also write the product information. Let's say Pandu, and then I'll click on this Google Lens. So it will take this text query as well as this image and do a reverse image search, and give me the list of products which it thinks might be relevant. And from here I can click on a website, go there, and see if the SKU is available for that product or not. Okay, so finally, after searching from multiple sites, I actually found the SKU here. You can see it. So this has been helpful. Now I can just go and use manual entry and put the SKU here, and similarly save it. So that was about the search SKU, and have some more features here. So as the product is processed, I have this product confidence option. Usually it does not works on the lower threshold, because the bounding box are only returned with the defined threshold, but I can go upper values and then select and see at higher confidence what products are selected. Gives me a good idea on to select how a particular confidence threshold will work. Interesting thing is I can just put it to lower and then process this image again, and then sequentially move my slider here to see at what confidence level this will actually work best for me. Interesting thing also here is the price tag detection. So you will see that these smaller detections here, these are price tags. And usually on shelf environment, what happens is you will have multiple products, but a very limited price tag, because one price tag will be representing multiple products there. But it is really hard to figure out that what price tag belong to what product, because it's not properly labeled or connected. So my goal has been to figure out the closest bounding boxes to the price tag, and then once the product is recognized, using the SKU, do a voting to select the best matching price tag for that product. And once you click on a product, you can go to this I button to see the detected price tag. Although in this case the price tag is not clear, so it is not recognized, but it does work in most of the cases. Okay, so this was about processing multiple images. I also have one more interesting use case for this, and this is called planogram mode. What this allows is, if I have multiple images taken off the shelf from different angles, but I want to combine all of those images to get the insight for the whole shelf. In that case, this planogram mode is really helpful. I have an example image here for this. So I'll just select these 4 images. I'll just show you what they look like. So these are images taken from different angles. And what this planogram mode actually does is it will take all of these images, combine them, stitch them together, and then do image recognition on the combined image. So I would really need to put the confidence threshold lower for this, but you get the idea. This is a combined image, and the product is detected in the combined image. For example, if you see here, this product is detected with the correct SKU, but the same product is not detected, and some other product is being recognized here. So it's easier for me to go to recommended and then select a matching image and save it to the database. Now what happens is, if you see for these 2 images, product image is predicted, which is not matching properly. So now I will process this again, and you will see for all the detected products from this image, the SKU predicted for that product is actually same. So it only takes like few of the attempts. Once the our internal team starts to organize these things and do human feedbacks, the pipeline automatically starts to recognize the products. And after going through few iterations, once our database is complete, the overall pipeline works really, really well and is able to recognize most of the products along with its SKU information. And once this pipeline is ready, we can use the background workers to ingest images on a regular basis and then produce statistics to generate meaningful insights for a brand, where their product are located, how well they are shown in the shelf, what is their price value, which is listed in different areas. So those kind of insights can be generated. We also have data delivery in the development in the pipeline, so that we can go and look for all the available products in our database, possibly modify them, search through them, and improve the pipeline. So this has been an ongoing project and a lot of things have been developed, but the main gist for this product was the image processor, which I have shown you right now. And the main highlight of this UI is the basically this HTML canvas, which allows to show the bounding box of the product as well as interact with it. So when I hover onto this, it shows the product information. When I click on it, it shows a quick modal to improve the pipeline. That is, to just user can click on yes, and this new image along with the predicted image SKU will be added to the index. You see the similarity is 85%, right? But if I process this image again, because the same image was indexed, you will see a similarity score of 100% because the same image has been matched. So if I go to the top prediction, you will see also get this red dot here, which shows that this is the same image. So I can also remove this prediction if I did it by mistake, and next time when I process it, it will again come back to 85%. So the pipeline improves in real time. The more indexing you add for a product, the more it will start recognizing it. And when the product is recognized with the same SKU, they will get the same color. So by looking through it, you'll get an idea that okay, these all products look same, and then their borders also have the same color, which means they are all recognized with the same SKU. So that also gives you a good idea about how well the pipeline is working to recognize these products. So this was all about the retail analytics application. I know this is a small part. This is only the demo for image processor, but trust me, a lot of things are in the development, and I hope so that in the coming years, this will be available to use. Although this is again part of a commercial project, so I'm not sure if I will be able to open source it, but this has been development, and I just wanted to show you the cool things which I have been working on. Okay guys, that was all for this video. I hope you enjoyed it. Please do like and drop a comment. That will help me to improve the ranking of this video, as well as help me motivate me to bring more such content to you guys.